In this video, we are going to focus on solving for exact values of trig functions. So this says algebraically solve for the exact values of all angles in the interval 0 to 2 pi that satisfy the equation cosine cubed of x equals cosine of x. So we want to figure out what does x equal that are going to make these two functions equivalent. And the first thing that I like to do is I like to just look at Desmos, and I like to see how many answers am I looking for between 0 and 2 pi. So let's go ahead and pull up Desmos real quick and just analyze what does this look like. So I'm going to make sure I'm in radians. I'm going to change this from 0 to 2 pi. The rest of it I'm not going to worry too much about changing. But this is going to give me a really good idea. And I'm going to say cosine cubed of x. Desmos doesn't like it when you do it that way. So cosine of x, and then put the cubed on the outside. It's cosine cubed of x. I like to just plug it in a couple different ways to make sure that it stays the same every time. So there's cosine cubed of x, and we want to see when does that cross cosine of x. They are equivalent here, 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 and here. So we are looking at between 0 and 2 pi, and we actually have all of our answers here, but the question says algebraically. But because we have the answers, we can check our work. So the answers are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi is outside of the domain, and I'll show you why when we flip to that other screen. And so we are looking for 4 answers. So the reason why 2 pi is outside of the domain is because this is rounded. And rounded means that does not actually include. The square includes and the round does not. So this says algebraically solve. We actually already know what our answers are. We could write them off to the side. X equals 0, pi over 2. I think it was 3 pi over 2. Let's see. There were 4 answers. I think it's pi and then 3 pi over 2. So we can put those over here just to start. And then we'll solve this algebraically and make sure that our work matches that. So when we're solving this, we have so many different ways to do it. I would recommend getting everything to the same side and setting it equal to 0 so we can use the 0 product property. And so we're going to have cosine cubed of x minus cosine of x equals 0. I subtracted that cosine over. I could factor out one cosine from each of these. So I'm going to have cosine of x times cosine squared of x minus 1 equals 0. And now I'm ready to solve. Both of these factors we're setting equal to 0. And so one factor we set equal to 0 is going to be cosine of x equals 0. And we want to know where on the unit circle does cosine equal 0. So you can either think through it, and you know that cosine equals 0 at pi over 2 and 3 pi over 2, or you can use this table here. And so using this table here, cosine is here, and the first time it equals 0 is pi over 2, and then it equals again 0 at 3 pi over 2. Now we need to set our other factor equal to 0 and solve. So we have cosine squared of x minus 1 equals 0. I'm going to add 1. Cosine squared of x equals 1. And then I need to take the square root. And when I take the square root of 1 is actually going to be plus or minus 1. So we want to find the positive or the negative 1. And again, we can analyze through this because we know the unit circle pretty well. Cosine equals 1 at 0, and then it equals negative 1 at pi, and then it equals 1 at 2 pi, and so forth. And if you're having a hard time remembering the unit circle, here's our table right here. And again, we're looking at cosine. At 0, it's 1. At pi, it's 1. This should be a negative 1 on here. And then 2 pi, it's 1. So now we just want to check our domain, and do these fit within the domain? Well, 0 to 2 pi without touching 2 pi. This is in the domain, this is in the domain, this is in the domain, this is, and this is not. And so our final answer in numerical order would be 0, pi over 2, pi, and then 3 pi over 2. And that matches exactly what we got on Desmos.